Hi there. So today we're going to be solving a problem. We're going to be solving rotate image, and it says you are given an n by n 2D matrix representing an image. Rotate the image by 90 degrees, which is clockwise. You have to rotate image in place, which means you have to modify the input 2D matrix directly. Do, do not modify do not allocate another 2D matrix to do the rotation. Okay, so for example, over here, right, we're rotating it by 90 degrees. So this will come here. So if you notice, you see that before it was 1, 2, 3. Now it is 7, 4, 1. So it's shifted by 90 degrees. So 7, 4, 1, and then 1, 2, 3. Then over here, we also shift 2. So now this shifted here, so it's 3, 6, 9, and then 8, 5, 2. Okay, 8, 5, 2. So we're moving it by 90 degrees. Okay, now in this example, still similar. We're moving it by 90 degrees, so this moved to here. So instead of 5 being here, it's now here. And instead of this being here, it's now here. Then instead of this being here, it's now here. Okay, so that's how it's working. And I'm going to be using Python. I'm going to be using Python to solve this problem. I hope you can hear me. Let's see. So in this problem, what I plan to do is I'm going to run a row loop where row ranges from 0 to n over 2. And within this loop, we're going to return a nested loop where column ranges from row to n minus row minus 1. And these loops traverse the groups of 4 cells in the matrix. And in this nested loop, we're going to perform 3 swaps. So the first swap is going to be the value of the top left cell with the value of the top right cell. So if you remember, we're shifting it by 90 degrees. And then the second one is going to be the value of the top left cell swapped by the value of the bottom right cell. And then the value of the top left cell swapped by the bottom of the bottom left cell. And the current group of 4 cells has been rotated by 90 degrees, so we can now move on to the next iteration. So what's happening is that we're just going to be rotating this every single time by 90 degrees. So we're going to be swapping it basically. And we're going to keep on repeating this process until we're done. So the first thing I'm going to do is I am going to initiate my length of my matrix. So n is equal to the length of matrix, and then I'm going to say for row in range n over 2. So the 2 slashes are because I want to round it, and I'm going to say for column in range from row, and then n minus row minus 1. So I'm going to say matrix of row to the column, right? So for each individual one, comma, matrix of column to n minus 1 minus row. I'm going to be moving it. Okay, so I want to move it by 90 degrees. So I'm basically reassigning, and I'll continue to keep doing this until I'm done. So it's going to be matrix of call. Oh, sorry. I might be muted, so still pay attention, okay? So as you can see, what we're doing here, we're just swapping it basically. We're not done. We still have one more condition. So want to swap matrix row call comma matrix n minus 1 minus call row is equal to matrix n minus 1 minus call and row matrix row and call, and then we are going to keep on doing this right for every time that we have a column, and we are going to return matrix. So the time complexity of this is O of n squared, and the space complexity is O of 1 because no extra space is being used. So before we test it out, let me check that my solution is correct. As you can see, this worked. So like I said before, the time complexity is O of n squared, and it's O of n squared simply because each cell is read and eaten once, and the space complexity is O of 1 because we're not using any extra space. So as you can see, we're just reassigning the values at a 90-degree angle to make sure that everything is swapped at the right time. So yeah, thank you so much for watching, everyone. Have a good rest of your day, and I pray you have a lovely study session. Thank you.